I'm Sarah Wilson and you're listening to the Roots and All podcast. I'm here to help you get growing. Join me as I explore everything plant related both indoors and out and provide the information you need to create your perfect green environment. Hello and welcome to this week's episode of the podcast. This week is somewhat of a follow-up to my interview with Jeff Lowenfels in episode 51. Following that interview, I found myself asking a few more questions, particularly about how we're progressing with research into mycorrhizal fungi here in the UK. So here I am talking to Petra Guy, who's based at Reading University. Petra looks mainly at woodland health from the perspective of mycorrhizal fungi, but we cover a lot of garden territory too, including proprietary fungi mixes, composts and replant disease. Petra starts by describing her work.
I've got several projects underway at the moment. In one, I'm looking at soil translocation. So this is this procedure that's quite often carried out for mitigation purposes. For example, when ancient woodlands are destroyed, which is something that's happening quite a lot at the moment in the UK with HS2 and so on. And what they do is they take the soil from the ancient woodland and then move it to another site. The idea being that it preserves soil flora and fauna. And in the HS2 documents, for example, you can read that one of the reasons is to preserve mycorrhizal fungi. However, I've not found any evidence that this, so far, I haven't found any evidence in the literature that this works. There is some evidence. I've seen one paper on a grassland project to conserve arbuscular mycorrhizal fungi, and that did seem to work. But Tarmac are very interested in getting some actual proper evidence-based research on that, and we're working with them at one of their sites to look at whether this soil translocation does preserve ectomycorrhizal fungi. So that's one big project. Another one I've just finished is I'm looking at whether the amount of trees that associate with different mycorrhizal types, so whether they associate with arbuscular or ectomycorrhizal fungi, and whether that affects herbaceous plant species. So the idea is that herbaceous plants associate predominantly with arbuscular mycorrhiza, whereas woodland trees in the UK mainly associate with ectomycorrhiza. So if you're a herbaceous plant and you want to establish in a woodland, you might find that there's a restricted amount of arbuscular mycorrhizal inoculum for you. So we're having a look at that. We've got a big data set from CEH that we're looking at to see whether if you've got more arbuscular mycorrhizal trees and shrubs, do you have richer and more abundant herbaceous plants? And that's important because obviously those herbaceous plants provide food sources and habitat for birds and insects and so on. So we want to do everything we can to improve herbaceous plant species richness. And there does seem to be a smallish but a positive effect. So that's quite interesting. Another big project I'm working on at the moment is looking at the mycorrhiza of oaks. So I spent wonderful last summer, travelling all around the UK, collecting samples from oak trees all across the country, and we're just about to get some data back on that. So they're the main projects I'm working on at the moment. Could you maybe explain the difference between the arbuscular and the ectomycorrhizae? Yes, that's quite important, especially for gardeners as well. It's quite important. So ectomycorrhiza predominantly associate with trees, not exclusively, but with trees in the UK, you will mainly find ectomycorrhiza, and you can see those on the roots. They kind of cover the outside of the root like a little furry sock. Quite often, they're quite cute. Some trees also associate with arbuscular mycorrhiza, a lot of your fruit trees and so on. And most of your herbaceous plants associate with arbuscular mycorrhiza. And they're a different fungal species, and they penetrate right into the roots. You can't really see them with the naked eye if you look at them. So they're quite important for your plant types in your garden to sort of know which ones associate with arbuscular and which ones associate with ectomycorrhiza. So I think this might tie into your project that you were talking about where the soil gets transported to another site. And how long can mycorrhizal fungi persist in the soil without a host?
Yeah, so that varies depending on the species and the conditions. There is a sort of long-term experiment going on at the moment looking at ectomycorrhiza. I think it's in its 6th or 7th year. And there are some species which are persisted in the soil for that long. It depends on what sort of propagules they produce, and that sort of thing. And it does vary depending on species. My supervisor, Brian Pickles, and a colleague, Jason Pither, are looking at the potential for some species to survive for thousands of years, perhaps, if they're preserved in permafrost. So, but in terms of horticulture, what you want to know is what might survive short time over winter or that sort of thing. And some arbuscular mycorrhizal will survive if your soil is stored and it's dried, and it depends on various things like had the arbuscular mycorrhizal propagated before you stored it. But if you're just talking about a few months, some will definitely survive.
Right. Okay. So I ended up getting in touch with you following on from a podcast that I did with Jeff Lowenfels, who's written a book about mycorrhizal fungi. And there were certain questions that I had that came off the back of that interview that I thought I could, this would be a really good thing to dig into further. And that's where you can help, I think. And I kind of took the example of an annual, such as a sweet pea. And I wondered if it has a specific mycorrhizal fungi associated with it, or could you assume that it shared one with a perennial species of the same genus, or even from the broader legume family? Or is that something that we just don't know yet?
There is evidence that, particularly among ectomycorrhizal, that there is some specificity. So some ectomycorrhizal fungi tend to prefer to associate with certain hosts rather than others. But a tree, for example, will host lots of different types of mycorrhiza. And the same for herbaceous plants. I haven't seen as much evidence for specificity with arbuscular mycorrhiza, but I think there is some hints that it happens. But one plant will not just host one fungi. So you won't be looking for your specific sweet pea mycorrhizal fungi in order for it to be healthy. It will share several species with several other plants.
That's interesting because Jeff said, I think they are quite good at researching this in the States as well. And he was saying, if you can look up the mycorrhizal associations of species online. And so being a sweet pea lover, I did go and have a look to see if I could find that information, and I couldn't. Do you know if that kind of information is available online anywhere?
I haven't found it. There are some databases with some information about fungi that have been found in a certain association with certain plants, but that's not to say that they're the only fungi that plant will associate with. It's just they may have been found with that plant, growing on that plant. I had a little look for sweet peas as well, because I know you like your sweet peas, but I couldn't find any information about what type of fungi have been found, particularly with sweet peas.
No. So if you were kind of, again, hoping to cultivate your own particular batch of mycorrhizal fungi, I was wondering if you grew sweet peas successfully this year, you could actually store some of the soil that came from around them over winter and then use it to when you're planting up maybe getting your seeds going or planting up your seedlings the following year.
So if you took soil out of your bed, for example, and stored it over winter, then you would expect some of the arbuscular mycorrhiza in that soil to survive. You might then have an issue that you're also storing soil pathogens, and then when you plant your new batch of sweet peas, there's a bit of a race between them, who's going to colonise them first. If you use shop-bought compost, you wouldn't have that because it's sterilised. I think the issue is, I suppose, if you're growing something like sweet peas, for example, the seed itself stores a lot of nutrients, so it's probably not that important initially. You could do something like take shop-bought compost and add inoculant to it, but then shop-bought compost often has fertiliser and so on in with it to feed the seed. So, on the one hand, you don't need the mycorrhizal fungi because it's got the fertilisers in the soil, and secondly, it would also probably interfere with the colonisation because the seeds would access the fertilisers they wouldn't need the mycorrhizal fungi. So, it's a bit difficult to say whether you need to or not, really. I think it would be quite an interesting experiment to try both and see, are my seeds healthier with my garden soil or with this shop-bought compost? If you're then going to plant your plants out into the soil anyway in a quite short space of time, that will pick up fungi from the soil pretty quickly. So it wouldn't be necessary from that point of view either.
No. So when you mentioned the shop bought compost, if they've got a fertiliser in, does that encourage the growth of the mycorrhizal fungi, or does that just feed the plant until it gets established?
That's right. It feeds the plant and then interferes with the colonisation, so that the colonisation will be less likely to occur if you've got the fertilisers in the soil.
Okay. So I did touch on the efficacy of proprietary mixes with Jeff, and he seemed quite surprised that the UK formulae don't often state which species are included, and they don't have a use by date on the packaging, and which, to my knowledge, and in the UK of going around to kind of trade shows and things, I haven't seen that information on there. I do remember reading research that was carried out by Glyn Percival, and he trialled the use of mixes in conjunction with tree planting, and he concluded that there were no benefits. Now, that was a few years ago. Is that still the prevailing thinking?
Well, it's difficult, isn't it? I had a look through some UK mixes, and I couldn't find any which told you what was actually in there, whereas if you looked at some US websites, they did actually list the species. Some UK products did actually say whether they contained ectomycorrhizal or a buscular mycorrhizal, so that was quite useful, because if you're planting trees and you're using an arbuscular mycorrhizal product, that may not be particularly useful depending on the tree species that you're planting. And it does seem counterintuitive. We know the plants need the mycorrhizal fungi to survive, so why wasn't there any effect? And I suppose that just depends on if you're planting the plant in the soil. They might not have needed it because there's plenty of mycorrhizal fungi in the soil. How old was the product? It probably just depends on so many other factors that you can't isolate. I think probably overall, if you use a product, you're not going to cause any harm, but it's whether or not it's actually going to be that useful to you, depending on the situation in which you're using it.
Yeah, that's true. I mean, it would be good to know, because I noticed as well that on a particular council website that I looked at, they had a kind of planting guide for contractors, and one of the things was to use this proprietary mix, and that was that was part of the contract, and obviously that's public money that's being spent on that. I'm getting on my soapbox now, I don't mean to, sorry, but if that's not been proven to be effective, that it's a kind of financial issue, I suppose, as much as anything else.
And I suppose there are some work where it shows that it is effective, other work where it shows it isn't, and it depends so much on the circumstances on which it's used. If you're planting trees in a very fragmented little bit of roadside where fungi might not have been able to colonise, and there may be nothing there and the soil may be very poor, then it may be something that's actually going to quite help a lot. So it could depend on lots of factors how effective it is.
If I take a rose out of my garden and I go to plant another one, there is such a thing as replant disease. I believe that nobody knows really what causes it, but the effects are that the plant that you plant back in that hole, if it's of the same species, quite often will keel over and die. As I say, they don't know why it happens, but it did make me think, well, if say I take my rose out, there's all the mycorrhizal fungi in the soil that's associated with roses, presumably. If I then put another rose in, it would kind of seem that maybe the rose should just get going really quickly because it's already got that network there.
Yeah, that sounds logical. I think so. Replant disease, as far as I know, is a combination of factors. So it might be fungal infection, it might be nematodes, and I think probably what happens is when you have a plant that's a long-established plant, it can pick up a lot of pathogens that are specific to that plant in the soil around it, as well as its mycorrhizal fungi. But because it's an old-established plant and it's well colonized with fungi, it's protected to a great extent against those pathogens. So it doesn't really mind. It's fighting them off all the time and it's fine. If you then take that plant out and put a new plant in that's perhaps not as well colonized, it's a younger plant, then there's a kind of a race that goes on between the mycorrhizal colonization and the pathogens. And it might be that the pathogens can just build up more quickly. And so the plant will then keel over and die because it can't colonize with its protective mycorrhizal fungi fast enough. So in that kind of instance, you might think it would be worth trying. Perhaps inoculating the plant before you plant it in a pot or something, and giving it a good start with mycorrhizal fungi before you put it in the hole, that might be something that's worth trying.
Yeah. Going back to what you were saying actually about planting trees, I guess particularly in urban locations, which might not be the most promising sites. And I was thinking about when you see trees planted in islands of paving, for example. And I kind of thought, well, especially in the urban environment, we quite often disrupt the soil. We pave over it, we destroy it, we remove it. And if we're doing that, are we potentially disrupting a huge and interconnected knowledge network that runs between these plants? And if we are, should we be building soil bridges as we might install hedgerows to make wildlife corridors? Is it something that we need to keep connected?
Well, there is a huge problem in the UK with fragmented landscapes, and there's also a big problem with the way that we're not looking after soil. So you look at a lot of those urban trees planted in those little tiny holes, or with tarmac right up to the base of the tree, and obviously there's no way for that soil to regenerate and survive. It's not having more organic material going into it to replenish it. So if you look at a lot of those trees, quite often they're not particularly healthy. And even in our gardens, if you've got a little garden, it's a new garden, it's fragmented, it's cut off from the wider landscape, it could well be less healthy. And one of the main reasons for that is that you are cutting off sources of dispersal of organisms. So that comes from whether it's mammals, whether it's hedgehogs being able to get around, or whether it's fungi, spores being able to spread, and seeds and so on. So imagine you've got a large woodland, for example, that's then cut in half by a motorway. You've got these two separate fragments. If you've got a rare species in one but not in the other, if that species then dies, it's not able to sort of colonise across this divide, and so you're putting things at risk of extinction. So that's really sort of one of the main problems with fragmentation and the way that we're cutting things up. It's a big something that DEFRA, for example, are working on in a big way at the moment, trying to join up landscapes with hedgerows and things like that. And it's definitely something, if you've got any kind of land in the UK and you can join something up with a hedgerow, then it's definitely something that's worthwhile and very important.
Yeah. Well, when you were talking then, I wondered actually how far down does the mycorrhizal fungi exist? I mean, can it exist in subsoil, for example?
On the whole, you do get mycorrhizal fungi quite low down. Some people have found it on sort of lower roots. In my work, what I've mainly seen is the majority of it is living in the upper soil, in the organic layers, where you've got all the fine roots, and it's very busy up there foraging around amongst the organic soil, which is one reason why we really have to protect our upper soil and make sure that doesn't become compacted and eroded by activities that we do outside in the countryside and in the woodlands, for example, just compressing it with people walking and horses and bicycles and so on, and causing erosion. So, yeah, there's a lot goes on in those upper layers that we need to be careful of that upper soil layer.
Which would imply things like hoeing maybe sometimes aren't, or any way that disturbs that layer might not be a good thing.
Sorry, what were those things like?
Oh, hoeing. So if you're disturbing that layer.
Yes. I think it is, and that soil structure is also something that's very important. That if you look at older soils, woodland soils, for example, they've got very complex structure, very stratified layers, and it's quite important if you can preserve that and preserve your soil, and not dig around and hoe it and dig it, which is not something that people tend to do so much anymore. I don't think, is it, in gardens? No,
I think people are definitely employing no dig a lot more, which is great. But actually thinking about it, I'm a big fan of mulch. So if I put mulch on top of that organic layer, am I potentially smothering some of the mycorrhizal fungi, or am I just feeding it? Or does it depend on how much mulch I put on, I suppose?
I think it would depend on how much mulch. I mean, in the work that I've done with my oak trees, a litter layer followed by an organic layer was definitely a happy thing. That you had a lot more roots going on. Some of them would spread right up into that litter. So and normally in a sort of a more natural environment, you would get a constant feeding of mulch every year as your leaves dropped and your herbaceous plants died. We maybe tend to be a bit too tidy in gardens and not let that build up. So I think the mulching achieves that really. So I think, it is important to do that.
Mm. Yeah, I mean, thinking about trees, I wondered if you could maybe talk a bit about mycorrhizal fungi and carbon sequestration.
Yeah, so they can do a lot of carbon sequestration for several reasons, I suppose. One is that they are a large underground organism, so they're made of carbon amongst other things, so they're actually storing carbon in the soil because they're this large underground organism. Additionally, they're feeding plants and making plants bigger and healthier, so because the plant is therefore absorbing more carbon to grow, so they're contributing in that way. They also produce certain substances which sort of help bind the soil together and make the soil better at storing carbon. They have a big role to play in carbon sequestration, which is another reason why we need to look after our soils and make sure that function carries on.
Yeah, absolutely. I kind of tacked this question on. I don't know whether it's something you can talk about, but it was Susan Simard's concept of mother trees in forests. Do you know anything about that?
Yes. So Susan Simard has done an amazing TED talk on this, which I highly recommend. What she looked at was how one tree can pass carbon via the mycorrhizal network to another tree which has greater carbon demand. So the mother tree is a term that she used for perhaps older, more ancient trees in a woodland that are therefore more likely to have a more extensive mycorrhizal network connecting trees to each other, and also then potentially offering a good source of mycorrhizal inoculum because they might have built up a bigger collection of fungi. I think she was interested in forestry, but you might want to preserve these trees if you're cutting, because then they would be there when you replanted to quickly provide a mycorrhizal network to seedlings that you were growing. I think for me, one of the most important offshoots of that work that it highlights is not just the interconnectedness of trees and their fungal partners. And we don't anymore think about a tree as just an isolated thing growing in the soil. We know that a tree is tree plus mycorrhiza, and neither of them can exist on their own. So there is no such thing as a single unit of tree. And then we know that these mycorrhiza are connected to adjacent trees. So not only do you just not have a tree and mycorrhiza, you have a tree and mycorrhiza and other tree, and that becomes your bigger organism. But in turn, they're all dependent on other organisms for dispersal, and it just demonstrates how in nature there is no such thing as this single unit that can survive on its own, and that applies to us as well. We're humans, but we can't survive without our fungi and our bacteria that live on and within us. We wouldn't be alive without them. And in addition to that, we wouldn't be alive without nature that we depend on for food and everything else. So I think that interconnectedness is something that we need to really tune back into, because we can't live without it. And we're in danger of forgetting that at the moment. Yeah,
you're right, we are. I'm about, to my shame, I am just getting round to reading Wilding by Isabella Tree, and she talks about the trees that they had on their farm, and they did have some oaks, but they were standing on their own in the middle of a field, and a tree expert came out and said to them, well, they're not going to function particularly well just standing on their own as a single organism in a field of grass. But that made me think, well, how many oak trees would be enough to form a network, or is it just a case that the more you have, the better it gets?
Yeah, difficult question. Because you have these isolated oaks, for example, now, because we had this fashion, didn't we, with the capability to ground type landscape, and what was a big oak wood is now oak surrounded by parkland. And those trees will have retained their mycorrhizal fungi from those ancient woodland associations that they once lived in. But yeah, I would imagine that they're not going to be as strong as if they're connected to a bigger network, and if they're isolated, they're not going to be connected to that. So. Yeah, I don't know in terms of how many you need to make a strong network, though.
No, I mean, I think there are a lot of unknowns in it, but it is. You probably are maybe a little bit biased because you work in it, but from an outside point of view, this seems to me like a really exciting topic of research and an area for horticulture and so many other applications. Where do you see, this is a big question, but where do you sort of see the future of this research going? You know, is there anything particular that you think will come out of this that will, you know, really, really help benefit either, I suppose, farming or gardening?
I suppose I would like to see it applied more in terms of gardening. I mean, we could do with knowing a lot more about what's happening in our garden soils. What kind of mycorrhizal do we have in there? Are they a really useful pool of mycorrhizal that we need to preserve, particularly for perhaps some older gardens? And in newer gardens, can we use that information, perhaps just spread them into newer gardens? In terms of farming and forestry, you still see some practice in forestry which are not helping the soils or the mycorrhiza. So it'd be really nice if the message started filtering down a bit more quickly and being put into practice in forestry to actually look after our soils for future generations, so that we can still carry on with working woodlands and so on in generations to come, and we haven't found that we've actually destroyed the soils and they're not going to function anymore.
Yeah, seems a bit of a no-brainer, really.
Yeah.
All round. Well, I mean, that's all my questions. Is there anything that we've missed off, or, you know, are there any places you'd like to direct people to?
No, I mean, look at Suzanne Simard's TED Talks. They're great. Look at Paul Stamets' work on fungi. It's just absolutely fascinating and will make anyone fall in love with the subject if they're not already. And gardeners have got a great role to play in looking after their soils. So keep up the good work.
Thank you to Petra for taking the time to talk about her research, and thanks to you for listening. To play us out, here's Dr. Ian Bedford talking about a master of disguise. Let's just say if I was an insect, I'd have been a goner long ago, because I've seen plenty of these, but not realised what I was looking at until I got right up close.
With spring now underway, increasingly more plants within our gardens will be bursting into life, and with an abundance of fresh tender leaves and nectar-rich flowers, a vast and diverse array of invertebrates are being motivated into starting their annual life cycles. Life cycles that will be fraught with danger as the seasonal battles play out between predators and prey. A scenario that, over the past 400 million years, has honed and perfected stealth and weaponry for both defence and assault. And by natural selection, has produced some amazing ways for species to survive within the bug world, many of which can be seen in action whenever we're out in our gardens. One of these is the cunning yet highly effective system that crab spiders have evolved to catch nectar-feeding insects, such as butterflies and bees. Crab spiders are common in Britain, particularly in gardens where lots of flowers are grown, and they're easily recognised by their crab-like shape and their ability to walk backwards and sideways. Their front four legs are also longer and stronger than the rear four, almost resembling the pincers of a crab. Unlike most other garden spiders, though, crab spiders don't spin webs, but stay motionless, on or within a flower, holding their front legs wide open, waiting to catch their prey as it lands to feed. But bees and butterflies have relatively good eyesight, so why don't they see the spiders and avoid getting caught on the flowers? Well, the crab spiders are also masters of camouflage, choosing only the flowers that match their own body colours, of white, green or pale yellow. Also, with lightning speed, they snap their legs shut around their victim as it lands on the flower and inject a fast-acting venom through long, slender fangs. Within seconds, the victim is paralysed, unable to move, but appearing perfectly normal sitting on the flower, whilst underneath, the spider surreptitiously sucks out its victim's internal juices. Despite their predatory prowess, the crab spiders are not an aggressive spider, and are no threat to us. But for the arachnophobes amongst us, it might be worth taking a closer look before picking flowers from the garden.
You can download or listen to the podcast direct from the website www.rootsandall.co.uk, where you'll also find my blog and a sign-up form for the newsletter, which gives you a weekly roundup of content, plus the inside scoop on things like upcoming guests. Or you can subscribe wherever you normally get your podcasts. Email me with comments and feedback at podcast@rootsandall.co.uk. Follow me on Twitter, Roots and All, Facebook, Roots and All UK, and Instagram, Roots and All Pod. But please also check out my Patreon, where you can make a one-off donation or take out a monthly subscription to help support my work, because if you like what I do, please help me to continue doing it. Even if you make a one-off donation of £1, trust me, it all helps and I will be immensely grateful. So please go to Patreon and search for Roots and All.